Good evening all. Welcome to our lesson today. My name is Teacher Kirwa. I want us to go through patterns in properties of elements in the periodic table. So I want to welcome you to be free, feel in class in this chemistry hour just for a few minutes. So welcome. Let's continue. I hope you are ready to write. You have a pen, you have a book. I want to say you are welcome all. Now, so in front here, I've drawn a sample of a periodic table, just a section of it for the first 20 elements that we do in our life, in our chemistry in high school. So this is a periodic table having the first 20 elements, each of them in their own group. Now, as we begin, we are all aware that periodic table is arranged in order of groups and periods of elements. Metals, atoms that are in the same period have the same number of energy levels. For example, this hydrogen and helium are in period 1. So period 1 because they have one energy level. Period 2 include this, which have 2 energy levels, and then we have period 3 and finally period 4. So let us begin by number 1. The first pattern that I want us to talk about is atomic and ionic radii, or ionic and atomic radius. Now these elements here, we begin with, so this is group 1, this is group 2, this is group 3, this is group 4, group 5, group 6, group 7 and group 8 elements. When we were doing our discussions, we said these are alkali metals, alkaline earth metals, halogens and then noble gases. Now looking at atomic and ionic radius, let us begin with metals. So for metals we have group 1 and group 2. These are metals. So for metals down the group, atomic and ionic radius increases. So atomic and ionic radius increases down the group, and this is because this is due to increase in number of energy levels. So as we go down the group, lithium has 2 energy levels, sodium has 3 energy levels, potassium has 3 energy levels. Similarly, beryllium has 2 energy levels, magnesium has 2 energy levels, calcium has 3 energy levels. Beryllium has 2 energy levels, magnesium has 3 energy levels, calcium has 4 energy levels. So because of the increase in the number of energy levels, looking at the 3 of them, for example, lithium is 2,1, sodium is 2,8,1, potassium is 2,8,8,1. So this one has 2 energy levels, 3 energy levels, 4 energy levels. For this reason, the atomic and ionic radius increases down the group. Second point that I want us to note about atomic and ionic radius is that for metals, atomic radius is larger than ionic radius. So atomic radius is larger than ionic radius, and the reason also is because metals react by losing one electron. So because metals react by losing one electron, this lithium, for example, for it to be stable, it loses one electron, and so a stable lithium ion contains one energy level. Sodium has 3 energy levels. For it to be stable, it loses one electron, so it has 2, it remains with 2, 8. For potassium, it loses one electron again, it has 2, 8, 8. Now, so because they react by losing one electron, in the process, they lose entire energy level. So they do not just lose one electron in the outermost energy level, but also it loses the entire energy level. In the process, the atom is larger than the ion. So as we can see, this has 2, this has 1. This has 3 energy levels, 3 occupied energy levels. This one has 2 occupied energy levels. So in the process, it has less energy levels compared to that. Now, so that is for metal. Non-metals, for non-metals, again the same. So non-metals are group 7. Majorly we do group 7 and group 8. So for non-metals, the same thing happens also. The first point applies for all of them. Atomic and ionic radius increases down the group for the same reason. Due to increase in number of occupied energy levels. So this point is the same. As you move from fluorine to chlorine, the number of occupied energy levels increases, and therefore the atomic and ionic radius increases. Now, the second point about atomic and ionic radius in non-metals is that ionic radius is larger than atomic radius. For example, fluorine. So fluorine atom is 2, 7. Chlorine atom is 2, 8, 7. As we can see, this has 2 energy levels, 2 occupied energy levels. This has 3 occupied energy levels. Now, fluoride gains 1 electron to be stable. So if I can illustrate, this is 2, 7. So these are 7 electrons for fluorine. For it to be stable, it gains 1 electron. So fluorine gains 1 electron to be stable, and so we will have a fluoride ion. This is a stable fluoride ion. Now this fluoride ion gains 1 electron to be stable. There is one fact I want us to appreciate here. Always electrons, as we said, are negatively charged. these electrons in the outermost energy level, occupying the outermost energy level of fluorine, are negatively charged. The incoming electron is also negatively charged. So as it comes in, there is some kind of repulsion. That kind of repulsion makes the ion to be larger. So the reason we give here, we say ionic radius is larger than atomic radius. The reason is because nonmetals gain electron to be stable. It gains an electron which is repelled by the already present electrons. So the incoming electron, as I've said, the incoming electron is negatively charged. The electrons already present in the atom are negatively charged. So as the electron comes in, it faces some kind of repulsion. That kind of a repulsion force makes the ion to be larger. So the repulsion force we can say this repulsion makes the ion to be larger in size. So that is a point I want. It is always important to grasp that as the incoming electron is repelled, then it adds some size. So it becomes, the ion becomes larger than the atom. So that is for metals and non-metals. So that is atomic and ionic radius for non-metals. Property number 2. Property number 2 that we talk about is melting and boiling points. Melting and boiling points. Now, melting and boiling points, when a substance is heated, definitely it melts, then it boils. Now, here is something I want us to grasp again. When we talk about melting and boiling points, it has to do with the forces of attraction in an atom. So the first thing I want us to note is that the stronger the forces of attraction, the stronger the forces of attraction in an atom or a substance, the higher the amounts of energy required to break them. Hence, the higher the melting and boiling points. That the stronger the forces of attraction, the higher the amounts of energy required to break those forces, and therefore the higher the melting and boiling points. So that if the forces of attraction are strong in an atom, then it will require higher amounts of energies to break, and that means we will have stronger forces as higher melting and boiling points. For when we look at group 1 and group 2, metals in group 1 and group 2, looking at this atom, lithium atom, for example, lithium atom here has 2 energy levels. Potassium has 4 energy levels. Therefore, the forces of attraction in potassium are weaker than the forces of attraction in lithium. So, in such a case, potassium will have a lower melting and boiling point than lithium. So we can say potassium has a lower melting and boiling point. So potassium has a lower melting and boiling point than lithium due to weaker forces of attraction. In potassium than lithium. So generally we can say melting and boiling point decreases down the group. That is, lithium here will have a higher melting and boiling point compared to sodium, compared to potassium. Similarly, beryllium will have a higher melting and boiling point, followed by magnesium and the lowest calcium. The reason is because there is decrease melting and boiling point decreases down the group due to decrease in forces of attraction. So as the forces of attraction decrease, then the melting and boiling points increase. Definitely we are all aware that if we have strong bonds between certain kind of individuals, then it will be difficult to break those bonds because you require a lot of energy or skill. So that is for metal. For non-metals, that is example we use for non-metals is group 7 and group 8, halogens and noble gases. So for halogens and noble gases, intermolecular forces of attraction increases down the group. Intermolecular forces of attraction increases down the group. Therefore, melting and boiling points will also increase down the group. Now, melting intermolecular forces of attraction holding particles together in group 7, halogens, the intermolecular forces of attraction increases down the group. Now fluorine, these are group 7, just to give an example of that. Group 7 we have fluorine, chlorine, bromine and iodine. These two are gases at room temperature. This one is a liquid. Bromine is liquid at room temperature. Iodine is a solid at room temperature. Now, gases, liquid, solids, kinetic energy or kinetic theories. When we learn kinetic theory, we say the forces of attraction are stronger in a solid than in liquid, and the forces of attraction are weaker in gases. Therefore, in group 7, as we can see down the group, there is increase in forces of attraction. That is why it changes from being a gas to being a liquid to being a solid. And that translates to what we've said here. So the intermolecular forces of attraction increases down the group. And because intermolecular forces of attraction increases down the group, then melting and boiling point will also increase down the group. So that is melting and boiling points for both group 7, for both metals and non-metals. So far so good. So property number 3 that I want us to look at is called ionization energy. Ionization energy. Now, ionization energy is defined as the minimum amount of energy required to remove the outermost, the electron in the occupied outermost energy level of an atom in its gaseous state. That is how we define ionization energy. It is the minimum amount of energy required to remove an electron from the outermost occupied outermost energy level of an atom in its gaseous state. Quickly, looking at this, we have already mentioned that forces of attraction are strong in lithium, weak in sodium, weaker in potassium. So the weaker the forces of attraction, the stronger the forces of attraction, the stronger the forces of attraction, the higher the ionization energy. The stronger the forces of attraction, the higher the ionization energy, and vice versa. The weaker the forces of attraction, the lower the ionization energy. Now, so here we expect that potassium will have a lower ionization energy compared to lithium. So generally, again, we can say ionization energy decreases down the group for metals. So because we said forces of attraction decreases down the group, then also ionization energy decreases down the group, because as the ionization energy depends on the forces of attraction. So if the forces of attraction are weak, then ionization energy is also weak. If the forces of attraction are strong, then ionization energy, the ionization energy will be higher. Now, one point I also want us to note. So we've talked of lithium, sodium, and potassium. Now, beryllium and magnesium, for this case, 2, 2, magnesium is 282, calcium is 2882. Beryllium, magnesium and calcium loses 2 electrons to be stable. It has 2 electrons in the outermost energy level. Magnesium, for example, so magnesium has 2 electrons in the outermost energy level. So it loses these 2 electrons. Point is, the 2 electrons are not lost at the same time. One electron is lost first, and then the second electron is lost later. So these 2 electrons are lost in 2 stages. Now, when the first electron is lost, we call that one first ionization energy. When the second electron is lost, we call that one second ionization energy. So, group 2 elements, beryllium, magnesium and calcium, have first and second ionization energies. For aluminium, for example, and boron, aluminium loses 3 electrons to be stable. So for aluminium 283, it will have first ionization energy, second ionization energy, third ionization energy. So this will have 3 ionization energies. This one have 2 ionization energies. Group 1 have first ionization energy. So first ionization energy, first and second ionization energies, first, second and third ionization energies. There is a point I want us to grasp there. Second ionization energy is always higher or larger, is higher than first ionization energy. Second ionization energy is higher than the first ionization energy, and this is because once the first electron is lost, once the first electron is lost, the remaining electrons are held more closer. Once the first electron is lost, the remaining electrons are held even more closer. Now, one analogy, I want to give an analogy about this. If somebody, say a thief or whoever, breaks into your house, then you have, say you locked your door using a tricycle, say 264 for example. Somebody comes and break into your room by maneuvering, by cutting or whatever, by tampering with this padlock. Now what you do after your room has been broken into, you will, number 2, you will buy a bigger padlock. So if the same person is coming the second time, then it means he or she will require to use more energy than when he was breaking into the first time. Similarly, when an atom loses an electron, it prepares for the second coming. So when it loses one remains. So this one that remains is held even more closer. When it is held more closer, the second energy now will be higher. More energy will be required to take off this one. And so we say, once the first electron is lost, the remaining electrons are held even more closer. And that makes the second ionization energy higher than the first. 3, 4. Number 4 is electronegativity. Electronegativity. Now, electronegativity is the ease to gain an electron. How easy can an atom gain electron? So this applies for group 7 elements, the halogens. So for halogens, fluorine, because we said forces of attraction increases down group 7. Intermolecular forces of attraction increases. Then that means fluorine, the electronegativity decreases down group 7, so that fluorine is more electronegative than chlorine. Which is more electronegative? You see, we have chlorine, fluorine, bromine, and iodine. Now, fluorine is more electronegative than chlorine. Chlorine is more electronegative than bromine, and bromine is more electronegative than iodine. Okay, so that is it. So it decreases down group 7. That means fluorine is the most electronegative. So fluorine is the most electronegative atom for that matter. Number 5, and almost the last one for today. So number 5 is electrical conductivity. Electrical conductivity, just 2 points there. One point about electrical conductivity is that all metals conduct electricity due to presence of delocalized electrons. All metals contain delocalized electrons. Metals, we have group 1, we have group 2, we have transition metals here. So group 1, group 2, transition metals, group 3, these ones are metals. Sorry, this was group 3. So these are good conductors of electricity because they have delocalized electrons. The higher the more the number of delocalized electrons, the higher the conductivity. The more the number of delocalized electrons, the higher the conductivity, which means that aluminium is a better conductor compared to magnesium, better conductor compared to sodium. Aluminium has 3 delocalized electrons, magnesium has 2 delocalized electrons, sodium has 1 delocalized electron. So aluminium is a better conductor because it has 3 delocalized electrons. Finally, on electrical conductivity, all nonmetals are non-conductors of electricity. electricity. Reason is because they do not have no delocalized electrons. So because they do not have delocalized electrons, they are non-conductors of electricity. So those are 5 properties that we can talk about broadly on a larger perspective. I just forgot to mention that atomic and ionic radius, our closing remark, atomic and ionic radius increases across the period. Due to increase in nuclear charge. Atomic and ionic radius increases across the period. This is a closing point. Atomic and ionic radius increases across the period due to increase in nuclear charge ama nuclear, some say nuclear attraction. Still okay. So magnesium will have a higher atomic, a smaller atomic radius. Not, sorry. This should be decreases. Atomic and ionic radius decreases. Sorry. Atomic and ionic radius decreases across the period due to increase in nuclear attraction or nuclear charge. So sodium will have a higher atomic and ionic radius compared to magnesium. Reason, because of this there is increase in nuclear attraction. Magnesium has a stronger nuclear attraction compared to sodium. Silicon has a weaker force nuclear attraction than chlorine, and therefore chlorine will have a smaller. So as we move across the period, the atomic and ionic radius decreases. So larger atomic radius, smallest atomic radius. Larger atomic radius, smallest atomic radius. Reason, due to increase in nuclear charge across the period. So guys, that is our lesson for today. I hope you liked it, you enjoyed it for the few minutes that we've been together. So thank you. We shall be doing this more and more, and I wish you all a blessed evening. Thank you for watching. Thank you for staying tuned. Subscribe, like the video, and share. Thank you. God bless.